Let me just show you where that pattern for the law of cosines comes from real quick, and then we'll do a couple of examples there. If you already understand this beginning stuff, you could kind of fast forward, skip through another part of that problem. We'll also do Heron's formula, the area formula later on in this video here. But when you work with the law of cosines, you won't have that completed friendship where you know the angle with the opposite side. And you got to use the law of cosines right here. And it works on any triangle. Just if you have a right triangle, you're going to do SOHCAHTOA. And if you have that completed friendship, you use law of sines. But here's the way the law of cosines problem works. If I want to work with this guy right here, okay, what you work with is that opposite angle and those two other sides. And so here's how it's going to work. We're going to go a squared equals, and you're going to work again with the opposite angle and those two other sides. So you're going to go like this side squared plus this side squared. So like b squared plus c squared. And it doesn't matter if you switch that order around because you're plussing now. Just use the other two sides. But usually I just put an alphabetical order there. But if I got numbers, it doesn't matter the order. So you go this side squared plus this side squared minus 2 times this side times this side. And again, that order doesn't matter. And then you do times it by the cosine of that opposite angle right there. All right, so that's the pattern that I want you to kind of have down. So if we started with this b, then you're going to go b squared equals, now you're working with that opposite angle of your b, and you're working with the a and the c as your two other sides. So you'll go a squared plus c squared. You go this side squared plus this side squared minus 2, that's part of the formula, times this side times the cosine of that opposite angle. It's called the law of cosine, so don't use a sine function right there. Use the cosine. It's called the law of cosines. And then the last one, same thing you could do on your own there, but just make sure you got it down. Your c squared, you're going to do this side squared plus this side squared minus 2 times that side times the cosine of that opposite angle of that angle c right there. So that is your law of cosines. And then this problem here, all I want to do is just show one quick part of this, how to find that x value right there. Notice on this triangle, I don't have an angle with this opposite side. Here I have the sides, but I don't know either of those opposite angles right there, so I can't use the law of sines. I have to use the law of cosines. And if you know those other two sides of that included angle, that's going to be straight like this pattern right here. So if I wanted to just solve that for the x, I'm going to go x squared equals, I'm going to do this side squared plus this side squared. That order doesn't matter. And I'll go minus 2 times the 25 times the 50 times the cosine of that opposite angle right there. That's how you're going to set that up. And if you go 50 squared plus 25 squared, you're still fine. If you go 2 times 50 times 25, you're still fine. Now this here, this to me is the easier problem where when you don't have to find the actual, like some angle sometimes there. But when you want to do this, you could plug that to your calculator, get a number, and then square root that answer right there. But you got to make sure you don't have any rounding error. On this one, I just take that whole entire thing, put it all underneath the square root, and then that's going to give me my final answer here. So if we show you that in the calculator real quick, so I like to hit my square root button first, and then I'll go 25 squared plus 50 squared minus 2 times 25 times 50, or you can use the times button right there, that's fine, or use the parentheses, and I'm going to do cosine of 150. And see how I already did that square root right there? So there's my x. And then the worksheet stuff, we'll have you round to the nearest 100 there, but for the quizzes and stuff, I think we're going to have you round to the nearest 10th there, so that's just going to be 72.7. But just read the directions, whatever we have you round to, then you're good. So that's how you're going to come up with that side right there. And then let's do a one where you need to find some missing angles, because that's a little bit tougher with all the solving stuff there. So let's just say I make up a triangle here, and I'm going to say, let's call this ABC, and we'll make this 7, 12, and 13. All right, now on the law of cosines, typically if you start working with the law of cosines, you typically use the law of cosines throughout that problem. You don't switch it to the law of sines. There's these weird special cases out there that sometimes you're gonna run into if you don't follow that. Also, it's a good idea because of those weird special cases. If you have to find all three angles, like if I just tell you to find the smallest angle will be opposite the smallest side, because then I would just find that angle B right there, okay, and then just find that one thing. But if I have you find all of the angles, when you run into these weird scenarios, what helps you out to not run into some of those weird scenarios, if you start with that largest side first. So I'm in the habit, I always start with that largest side first. Sometimes if you don't, you're still going to be just fine. But usually I just stick that with that largest side first, and then it doesn't really matter after that there. Okay, so what I'm going to do is work on finding angle A. So here's what I'm going to do. I'm going to go 13 squared. I'm going to use this formula right here, but I'm going to start with that 13 squared, which means I'm going to use this angle, and I'm going to use these two as the other sides right there. So I'll go 7 squared plus 12 squared minus 2 times 7 times 12 times the cosine of that opposite angle of that angle A right there. Now, when you got to solve for that, that's a little bit more involved to work that out. Now, your notes video kind of showed you just subtract things over and get everything on one side. And I'm going to show you a slightly different approach here. You know, you can choose whichever one you like better, but the main thing is you're not rounding to the very end of this problem. Now, when I do 13 squared, I know that's 169. And right here, this is going to be 49 plus 144. So I'm going to add those up. 49 plus 144 is going to give me 193. And then right here, see, this stuff is where you got to be careful on, because this is all kind of together as one big multiply thing there. So I'm going to go like -2 times 7 times 12 in the calculator. And that's going to give me -168 times this cosine of A. Now, sometimes people do weird illegal algebra here. They'll do 193 minus 168, and they'll just, that's just completely wrong. All right. Like if I gave you the problem, like 16 equals, or 169 equals 193 minus 168x, and I told you to solve that equation for that x, you're not going to combine those. Those are not like terms. This does not have an x attached to it. You can't combine those, right? So you would move the 193 over there and then divide both sides by that -168. So that's what I'm going to do here. I'm going to subtract the 193 from both sides. So those are gone. So if I go 169 minus the 193, that gives me a -24. And then that equals the -168 cosine of A. And now this is -168 times the cosine of A. So you need to divide both sides by that -168. And so you're going to get cosine of A. Now, negative over negative is going to be a positive, 24 over 168. If you want to reduce that fraction, you know, the calculator will reduce that fraction for you. Sometimes it can be reduced, sometimes it can't, but you don't really need to reduce that fraction there, okay? So the thing is, if you don't know that angle, that's when you use the cosine inverse of that. So I would not take this and get a decimal right here and put in the decimal. I would just take whatever that stuff is, those are equivalent, and then put that right there, okay? If you do ever really need to round, then round it to tons of numbers after the decimal. That way, if you round it to the nearest hundredth and nearest 10, then you're not having any sort of rounding error or anything like that, okay? And then, so when you do that in the calculator, you're gonna do cosine inverse of that answer. So you go up there and just hit enter on that, or just hit your second button, then the A and S for the answer there. And then there's going to be our angle of 81.8 degrees. So I'm going to have 81.8 degrees right there. And so once you get that angle, sometimes you will be safe just kind of saying, okay, if I know that this is 81.8, then you have that completed friendship there. Sometimes you'll be safe with using the law of sines after that, but sometimes you run into these other scenarios that I think you'll be safe if you just always stick with the law of cosines. That's like a general kind of rule there. Just if you start with the law of cosines, stick with the law of cosines the whole way through. So I'm going to do the law of cosines one more time. And at this point, it doesn't matter whether you use the 12 or the 7. I'm just going to stick with that 12. I'm going to find that next angle. And then once I get two angles, I can subtract from 180 to get the other one right there. Okay, so if you like this approach, that's fine. If you like the approach where they left everything in the calculator, you know, when you're watching the notes, that's fine too. Just practice it, make sure you're getting that right. And then if you need some questions, you gotta make sure that you're asking questions there. So then here, I'm gonna set this up again. I'm gonna go 12 squared now. So I'm working with these two sides, and then this as my opposite angle. So I'm gonna go 7 squared plus 13 squared minus 2 times 7 times 13 times the cosine of that angle C. And let's actually practice this one, just moving everything over without writing down so many numbers, okay? You need to subtract these two things over there to that side. So you'll have 12 squared minus 7 squared minus 13 squared. So you could have that all over there. And then that's equal to -2 times 7 times 13 times the cosine of that angle C. And then this is all multiplied by that. So to get rid of that stuff you're multiplying by, you got to divide both sides by that. So then you get cosine of C is equal to this 12 squared minus 7 squared minus 13 squared all over -2 times 7 times 13. All right, now what you could do here, you could hit cosine inverse right now and then plug all that in right there. Or you could get an answer for this, and then let's be a little bit careful how we're plugging that in. So if I plug this into the calculator, all right, so I'm gonna put all this in parentheses. I'm gonna put the top part in parentheses. So I'm gonna have parentheses. I'm gonna go 12 squared minus 7 squared minus 13 squared. All right, there's my numerator, and then I'm going to divide that. And I'm gonna need to put all that in parentheses because you don't want to divide it by one of the numbers and then you hit times and then it puts the 7 and the 13 up on top. You need to put your entire denominator in the parentheses. And I can just go -2. I'm just gonna go times 7 times 13. Boom, there's my whole denominator right there. And notice how you're getting this 0.4065. Now, if you're ever really desperate to round stuff and you're struggling with that, I mean, you could just put a bunch of numbers in there. You don't really want to round into the very end, okay? So you want to leave that in there. And then, like I said, what you could have done is hit cosine inverse and then plugged all that in there, and it would have given you that angle there. But if you have the cosine of C equals that, if you want to find that angle, then here's what you got to do. You're going to hit second cosine, all right? So get that cosine inverse, and either use your arrows and go in there and hit enter on that. That'll put that whole thing in there. Or if you don't like that, or I'll just hit enter on that real quick. Or if you don't like that approach, if I had this in there as my answer, right, you could also hit cosine inverse. And then I know this is a graphing calculator, but it has on the scientific calculators as well. You have an A and S and answer button. So to get your most previous answer up there, if you don't want to use the arrows, or if your calculator don't allow you to use the arrows, you can hit second, and then you could hit that A and S, that answer button, see, and it will take that whole entire thing and put that in there. Because if you just put in 0.4 or 0.41, you're going to have some rounding error with your answer, and then that's not good, okay? Especially when you're doing a buzz quiz, you're going to get all of those wrong. We'll make sure we're getting them all right there. So this is going to give us 66.0. So you could go 66 degrees. And then if you round to the nearest tenth, that's just 0.0. I think we have it set in the buzz where we'll accept that. But it says round to the nearest tenth if necessary. So if you get something like that, you could just use the 66. And then once you get that angle is going to be the 66, you could just now subtract from 180 always to get that third angle. So if I just go 180 minus the 81.8 minus the 66, that's going to give me 32.2 degrees for that angle. Let's see what I messed up there. All right, so this, I'm sorry, this we said was 66 degrees, my fault. And then this angle B is going to be your 32.2 degrees right there. All right, so that's pretty much all the stuff you got to be able to do the skill-wise with the law of cosines. Is one, just recognizing the pattern and then just doing the calculator work there. And then that's the hardest that the calculator work gets with that stuff right there. And then the last thing that we're going to give you is this Heron's formula to find the area of a triangle, right? So Heron's formula. I gave you that other little YouTube video there. It's just a couple minutes long. You can watch. There's another example in there. But Heron's formula is this. If you have a triangle, the semi-perimeter is you add up the sides and divide by 2. So if you have a triangle like that's little a, that's little b, that's little c, it's just a perimeter. S is just a perimeter divided by 2. So add up all the sides, divide by 2. And in your area formula for the triangle, you got this giant square root. You're going to take your semi-perimeter, you take your S, and then you're just going to take your S and you're going to subtract out each of the sides. The order doesn't matter. As long as you subtract out each of the sides, you'll go S minus A, S minus B, S minus C. There's the area formula for a triangle. And then notice the last section we did that side times the side times the sine of that included angle, we don't know any of the angles. So this is just a nice formula. You don't need to know the height to use your 1/2 base times height, because a lot of times it's difficult or impossible to find that. And then here you just need to know all three sides right there. So if we do an example, all right, so I believe this is like example 7 off of that 14.2 worksheet, but it gives us the three sides of the triangle are 12, 7, and 11. Okay, you don't even need a picture for that one if we give you all three sides, but your S is your semi-perimeter. So you're gonna add up the sides and divide it by the 2. So if you go 12 plus 11 plus the 7 divided by 2, that's going to be like 30 divided by 2. That's going to give you 15. Sometimes you'll get a nice number for that. Sometimes you might get like 15.5 or whatever. Just use a number for that or a fraction if you need to. And then all you're going to do to find the area, it's really simple. You're going to take that S, put that in there, and then you're going to take that S, you're going to go 15 minus each of the sides. And it doesn't matter which order. So I can go 15 minus 12, and I'll go 15 minus 11, and I'll go 15 minus 7 right there. And a lot of times I'll try to, you could plug it all in the calculator right there. A lot of times I think it'll easier to plug it into the calculator if you just do basic arithmetic, although you do gotta be careful with your subtraction, right? So you'll go 15 times the 3 times the 4 times the 8, and then you just plug that into the calculator. I typically would just jump there. I mean, you could plug that in there and get, hey, that's the square root of 1440, or you could just, you know, just plug it all into the calculator right there. I believe we get the square root of 1440, and then that's going to be like 144 times 10. So that's the square root of 144 times the square root of 10, which is going to be 12 radical 10 for the exact. And then we may ask you for the exact area. We might just ask you for the decimal answer. If we ask you for the decimal answer, then you'll plug that into the calculator. You can just go 12 times the square root of 10, and that's going to give us like 37.9 right there. So it depends on what we ask you for. If I then ask you for that exact answer, I would just plug everything into the calculator pretty much like right there, and would have given me that decimal answer there. Just hit that square root button first and then type all in, and then there's your area problem. Peanut butter Captain Crunch.